Welcome back. This is Mr. Hassan's Maths channel, and I'm answering now question number 3 from the October-November 2022 Cambridge Mechanics Paper 4 Variant 2 from the 9709 series. And this question here is about statics, and we have a particle of mass 0.3 kilograms is held at rest by two light inextensible strings. One string is attached at an angle of 60 degrees to a horizontal ceiling. The other string is attached at an angle of alpha degrees to a vertical wall. In the diagram you can see that the tension in the string attached to the ceiling is 4 newtons. So there's a tension acting in this direction, which is holding this thing up, and that's 4 newtons. So I'll put that as 4 newtons. Okay. Find the tension in the string which is attached to the wall and the value of alpha. So we have here the weight acting vertically down, okay, which is going to be 3 newtons, 0.3 times 10, which is G. And here we're going to have tension acting in this direction, okay, which is what we have to find. So we have to find this angle and this tension. Those are the two things we have to find. So what I'm going to do is I'm going to just kind of redraw these on this diagram here, just to I'll have to keep scrolling up and down. That's 4 newtons. That's 3 newtons straight down. And that's the T that we have to find. Okay, so I'm going to resolve forces here horizontally and vertically. Okay, so that we can deal with this question. The forces aren't at 90 degrees to each other, so it's better, I think, to just resolve horizontally and vertically. So I'm going to draw these two lines as guides, okay, and I'm going to, well, this is horizontal, this is vertical already, so the tension and the 4 newtons, I want to resolve them horizontally and vertically. So I've got to deal with the angles here. Now I know that this angle here is 60, so I can say this angle is 30, or I could say this angle is 60 if I want. I'll just do that way because it will help me understand what to do next on this side as well. And this side, this angle is alpha, and this angle is also alpha. Okay, this angle is also alpha. So if I want to resolve these forces now, the method that I like to use is actually going to come in very useful here. Okay, I want to resolve this force here first. Let's look at resolving, let's say horizontally first. Okay, it's in equilibrium, so the forces acting to the right and the left must be equal. To the right, you have this tension, but I want to resolve it horizontally. So to resolve it horizontally, I have to resolve it like in this direction here. So I'll just draw that. It has to be horizontal, it will be like this. Okay, that's the tension there. Let me just draw this on this side so that's a bit clearer. So this is going to be the tension times that I want to resolve in the direction going away from the angle given. Okay, going away from the angle given. So it's like, you could say, it's like this direction here. So it's opposite the angle. If it's away from the angle, it's always sine. So this is T sine alpha. Okay, that's the component of this force in that direction. And if I want to resolve in this direction, okay, this is going to be resolving in this direction. That's going to be T going into the angle cosine alpha. You can think about it as I'm trying to resolve on the adjacent side, which is going to be T cosine alpha. And for this 4 Newton force, you're going to have the vertical component going upwards, which is 4 times, now again going away from the angle given, is going to be 4 times sine 60. And here, going into the angle given, we'll say 4 times cosine 60. So when you are resolving in a direction that's going away from the angle given, you use sine. When you're resolving in a direction that goes into the angle given, you use cosine. So here, I'm going to resolve in this direction. It's going to be 4 sine 60. If I did in this direction, it would be 4 cosine 60. And what you'll understand is, supposing I decided to call this angle 30, because of course this is 90, that's 60, that's 30, then it will be the same answer. Why? Because this time I'd go into the angle, so I'll say 4 cosine 30. And cosine 30 and sine 60 are both the same. They're both root 3 over 2. And if I resolved in this direction, and I had this angle marked, I would have said 4 times sine 30. And cosine 60 and sine 30 are both of the same value, a half. So that's something we should realize, that the sine of an angle is the same as cosine of 90 minus an angle. So the sine of theta is the same as the cosine of 90 minus theta, and vice versa. Okay, but we chose to do it in this way, so I'm going to keep it like that. So we can see that horizontally we're going to have t sine alpha equals 4 times cosine 60. And vertically, we're going to have 4 sine 60 equals, and down you got 3 newtons plus t cosine alpha. So with this information, hopefully now we can find the value of t and alpha. So what I'm going to do first is I'm going to take this equation here. I'm going to write this as t cosine of alpha equals 4 sine 60. Okay, 4 sine 60 minus 3. So I've got these two angles. T sine, these two equations. T sine 60 equals 4 cosine 60. And t cosine alpha equals 4 sine 60 minus 3. Okay, now how can I solve these two equations simultaneously? Now the easiest way to solve these two equations simultaneously is to basically understand what we know, that when you divide sine of an angle by the cosine of the same angle, you end up with the tan of the angle. So if I divide these two, if I divide equation 1 by equation 2, the t's will cancel out, so I've eliminated the t. I'll get tan of alpha equals 4 cosine of 60 divided by 4 sine 60 minus 3. Okay, this is actually going to be sine 60, that's a half. So that's going to be 2 over 4 sine 60 minus 3. I can just put it in my calculator straight away anyway. I don't have to bother writing it in its exact form. So 4 cosine 60 over 4 sine 60 minus 3. And that gives me 4.3094. Okay, 4.3094. In fact, what I can do is just put, I want to find what alpha is. I could just put this as alpha equals inverse tan of all of this. 4 cosine 60 over 4 sine 60 minus 3. Okay, and that will give me alpha. So I can just take this answer here, inverse tan of the answer that I just got, and that gives me the angle 76.935, which is going to be 76.9 degrees to 1 decimal place. Angle should be measured in. Okay, and then the tension in the string. Okay, once we know what the tan of alpha is, which is this, we can then work out what t is. So I can say t is equal to 4 cosine of 60 over the sine of alpha. So I know alpha is this, so I can say t is equal to, and I can put this in my calculator. I can say 4 cosine of 60 divided by the sine of the last answer, and that should give me my answer, which is 2.053, 2.053, okay, 31. So that's going to, tension is going to be 2.05 newtons to 3 significant figures. So there we have our answer, or our answers to this question. This is only one part of the question. Okay, it's just 6 marks for that. All right, so not too bad. So what you have to remember is how to resolve forces. Okay, so as I mentioned, if you have, a force like this and you want to resolve it, and you've got this angle here, so let's say this is F and this is alpha. If I want to resolve this force in this direction, okay, it's a nice, easy way to remember things. If I want to resolve forces in this direction, I'm going to go into the angle, so I use cosine, because I have to go into the angle. It's like I'm finding the adjacent side. If I want to resolve forces in this direction, then I'll use sine because I'm going away from the angle. F sine alpha. If this was the alpha that I had, this would be cosine, this would be sine, because you're going into and away from the angle. But if this is alpha, you're going into that angle to resolve, you use cosine, away from that angle, use sine. That's important here and will help us to answer such questions. Instead of fluffing around trying to find this angle over here, or trying to find how do I express this angle over here, you can just look at this angle and say, okay, I want to resolve in this direction, into the angle, cosine, away from the angle, sine. Okay, so that's something that's important for you to understand. So I hope that was clear. Thank you for watching. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from this topic of statics can be found in the playlist that will appear in this section over here. You can watch my statics videos from my EdXL collection, which will be showing over here. Just take care that you realize that they use G as 10 as 9.8, not 10 as we did here, because this is 0.3 G, which is 3 times 10. They would say 3 times 9.8, so just be careful of that. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.